Alright guys, I'm the reporter for Group 2, and the project we did last week was the air conditioning, the commercial air conditioning lab. So the outline for this presentation is go over the learning objectives of the lab, basic overview of how a commercial air conditioner works, the calculations that are required, and the results that our group got. So first, students are supposed to pick up from this an understanding of the efficiency of an air handling unit, and there's more than one way of quantifying that. Next is the physical components of an air conditioning unit, and then also the variables in air conditioning equations that are used. So basic theory, which is simple enough, is hot air from the room is sent through, or it's drawn through by a fan, I guess the AC unit, which has has cooling coils, and heat is rejected from the entering warm air to whatever happens to be flowing through the cooling coils. And then that's sent to the fan and out to the room as cooler air. The different efficiencies you have are the coil bypass factor, which takes the air temperature coming in minus the air dew point, or the apparatus dew point, divided by the entering air minus the apparatus dew point. And then you also have the skip that one. You have the coefficient of performance. And this is the energy efficient ratio, I believe. So basically, your three main components of this unit are the heating loop apparatus, and basically, it's a closed loop system, and if you start here, air comes out of the hot tube, and it's drawn by the hot loop fan, which goes to the heater, and comes through, or enters the hot plenum, and exchanges heat with these two chambers, which would be your rooms, I guess, and then it starts to loop back over again. And also you have the cooling loop apparatus, where air is brought in from the room to an AC unit, which cools it down. It comes to the supply air fan, which, now that it's conditioned, it can be better controlled by going through a supply air heater to bring the temperature to the temperature that's desired in the room. And it splits into these two different ducts, one going to chamber A, one going to chamber B, and they pass through a valve box, which controls the airflow. Okay. And the required calculations for this lab are the actual heat transfer rate into each chamber, using the average values that we obtained when doing the experiment. Also, a plot of the temperatures versus the time for each chamber, and to also plot the coil line on the psychrometric chart, and then to determine the efficiency of the AC unit. And those two would be the energy efficiency rating and the coefficient of performance. So these are the results we got for the actual heat transfer rate into each chamber. Chamber A, we got 898 BTUs per hour. And chamber B, we got 260 BTUs per hour. This is the temperature versus time plot, which was done in Excel. And that's what we got for that. This is the coil line plotted on the psychrometric chart. And the efficiencies we got, first one for the energy efficiency rating, we got 8.62, and for the coefficient of performance, we got 253. That's it. Any questions?
So I have a question. So like on your graph of temperature versus time, what was the set point for both the chambers?
It was,
Can you show the graph? What was the set point like? What temperatures was it set to attain?
75
So,
degrees Fahrenheit.